So now we're ready to finish up part 3 of our notes. Part 2 was the 5 types of reactions. Go down to the bottom of the page and you'll see part 3. There are 2 categories of chemical reactions, exothermic and endothermic. Hear the word exit in exothermic, and thermic, thermal, heat. So exothermic reactions, the heat is exiting, they give off heat. You can feel the heat from these reactions. For example, if you have a fire burning, you can feel the heat coming off of that exothermic reaction. An endothermic reaction, hear the word enter in endothermic. So heat enters a reaction in an endothermic reaction. And strangely enough, even though heat is entering the reaction, it feels cold. Now, how is that possible? Well, for example, if you have an ice cube, an ice cube as it melts is an endothermic reaction. The ice cube must take in heat in order to melt. But when you hold that ice cube in your hand, it feels cold because it's pulling the heat out of your hand and into the ice cube. So endothermic reactions where heat is entering feel cold. Now, there are several signs that a chemical reaction may have occurred. There are actually 3. First of all is the formation of a gas. If you see bubbles and it's not just boiling, it's bubbling because of the reaction, then that is a sign of a chemical reaction. For example, vinegar and baking soda make bubbles. It's not boiling, it's reacting. Next, the formation of a precipitate. Now, I know you're used to precipitation, which is rain, snow, whatever, but this has a totally different meaning in chemistry. A precipitate is a solid that will not dissolve. And the solid forms and then falls to the bottom of the beaker as if it was precipitating. Maybe that's why they call it that. Next is a color change. Now, not all color changes indicate a chemical reaction, but most of them do. There are some physical reactions that do change color. For example, a rock of yellow sulfur, when it melts, will actually turn into a red liquid, but melting is a physical change. But most color changes indicate a chemical change. I'd like to demonstrate what a precipitate looks like in a chemical reaction. Here I have a small beaker, and I have some lead nitrate. Lead nitrate is a white solid that is dissolved in water here. Then I'm going to add sodium iodide, which is another mostly clear liquid. But when they mix, look at that. You have a very distinct color change. It's now bright yellow. Can you see the little flakes of solid in there? That's the precipitate. It's a solid that won't dissolve. Next, I'd like to show you the reaction between cupric nitrate and sodium hydroxide. Cupric nitrate is a blue solid, and I have dissolved it in water, and this makes just a pale, pale blue liquid. Now we're going to add sodium hydroxide, which is a white solid that has been dissolved in water. And watch this. See that dark blue solid that has formed? That is cupric hydroxide, and that's another precipitate. You can see the pieces of the solid floating around. So in the first 2 chemical reactions, we had a color change and we had the formation of a precipitate to indicate that a chemical change was taking place. Next, I'd like to show you the reaction of sodium carbonate and nitric acid. Sodium carbonate is a white solid dissolved in water, and nitric acid is a clear acid dissolved in water. See the bubbles? That's carbonic acid, which then decomposes into carbon dioxide bubbles and water. So you can see the carbon dioxide bubbles as they form. So in this reaction, we didn't have a color change or a precipitate. Instead, we have bubbles. And you can have any combination of those three or just one of the three to indicate a chemical reaction. There are, in fact, even some chemical reactions that are very boring because you see no color change, no bubbles, no precipitate, no nothing. They do react, but the reactants are clear and the products are clear. So I would show you one of those, but you'd be really bored. I think you'd rather watch grass grow.